Introduction to functions. In many instances, we assign to each element of a set a particular element of a second set. So here we have two sets, set A and set B. For example, suppose that each student in a discrete mathematics class is assigned a letter grade from the set A, B, C, D, F, which is our set B. And set A consists of our students. Okay, suppose that the grades are A for Adam, C for Cho, B for good friend, A for Rodriguez, and F for Stevens. This assignment that we did is an example of a function. Okay, when we assigned an element of the first set to an element of a second set, that is essentially an example of a function. So functions has this definition here. Definition 1, let A and B be non-empty sets. So this sets A and B must have elements. A function f from A to B is an assignment of exactly one element of B to each element of A. Therefore, for every element of A, there must only be one element of B assigned to it. We write f of A is equal to B if B is the unique element of set B assigned by the function of f to the element of A of the set A. If f is a function from A to B, we write it as f colon A mapped to B. Okay, this arrow here is read as mapped. Okay, that's why functions are sometimes also called mappings or transformations. Definition 2. If f is a function from A to B, okay, we say that A is the domain of f and B is the codomain of f. So the set A is the domain of A if these are the values that has an assignation from letter B. Okay, so domain is basically the set of the first set. Okay, the element of the first set is called the domain of the function if it's an element of the first set A. If f of A is equal to B, then we say that B is an image of A and A is the pre-image of B. The image of A is the result of the function given at the element A. Okay, and A is the pre-image or what is inputted in the function to result that image of B. The range of f is just the set of all images of elements of A. So if it is an image of the function, then it is an element of the range. But don't mistake range for codomain, okay? The codomain of f is the set of B where the images can be generated from. Okay? The range are the resulting values given the domain, given the pre-images found in the domain. Also, if f is a function from A to B, we say that f maps A to B. Or again, f is A mapped to B. Okay, now here we have the third definition and the introduction to functions. Let f sub 1 and f sub 2 be functions from A to R. Then f sub 1 plus f sub 2 and f sub 1 and f sub 2 are also functions from A to R defined for all x that is an element of A. By f sub 1 plus f sub 2 of x is equal to just f sub 1 of x plus f sub 2 of x. F sub 1 times f sub 2 of x is also equal to f sub 1 of x times f sub 2 of x. So here we are dealing with the sum of functions. Okay. Here we have the product of functions. How are you how are you going to solve for the sum and product of functions? This is given by the definition 3. Okay, example, we have here f sub 1 and f sub 2 functions from R to R. Okay, where f sub 1 of x is equal to x squared and f sub 2 of x is equal to x minus x squared. If we want to find the function f sub 1 plus f sub 2, again, f sub 1 plus f sub 2 of x is simply just f sub 1 of x plus f sub 2 of x. And f sub 1 of x is equal to x squared. Therefore, we have to add that with f sub 2 of x, which is x minus x squared. Simplifying this, x squared would be cancelled and you are left with x. So the sum of f sub 1 and f sub 2 is equal to x. Now, if we want to find the product of f sub 1 and f sub 2 of x, that's simply just the product of f sub 1 x and f sub 2 x of x. And this would give us x squared times x minus x squared. Solving this algebraically or simplifying this, we would have to distribute x squared, so that would give you x cubed minus x raised to 4. Okay. Now, here are the types of functions. A function is said to be one-to-one function if all values of our domain is assigned to just one value of y, and vice versa. Okay? You could not have a value in the range, or sorry, in the codomain where there is two values of x. Okay? You could not have it's not one-to-one if our y has two domain or two pre-images. If our image has two pre-images, it's only one-to-one if a pre-image has exactly one image and an image has exactly one pre-image. Okay, so a function of f is said to be one-to-one or an injunction if and only if f of a is equal to f of b, and that implies that a is equal to b for all a and b in the domain of f. The function is said to be injective if it's one-to-one. Okay, here we have to determine whether the function f from a, b, c, d to 1, 2, 3, 4, 5 with f of a is equal to 4, f of b is equal to 5, f of c is equal to 1, and f of d is equal to 3 is one-to-one. We could do this if we would do the mapping that we have in the previous slide. So for the first set, we have a, b, c, and d. And for our second set of, which is the codomain, we have 1, 2, 3, 4, 5. F of a is equal to 4, therefore a is mapped to 4. F of b is equal to 5, therefore 5 is mapped to b. B is mapped to 5. F of c is equal to 1, so c is mapped to 1. F of d is equal to 3, and d is mapped to 3. Since all of our images have exactly one image, all our pre-images 1, 3, 4, 5. Right, all of our images 1, 3, 4, 5 has exactly one pre-image. Therefore, the answer here is yes. It is 1, 2, 1. And you could see that in this solution here. Since the function f is one-to-one, since f takes on different values at the four elements of its domain. Here we also have to determine whether the function f of x is equal to x squared from the set of integers to the set of integers is 1 to 1. And the solution for this is that since there is a value of the domain, or there is an element in the domain that is mapped to the same image of 1, right? Because 1 and negative 1 in the codomain, okay, will be mapped to 1 in our the element of negative 1 and 1 in our domain would be mapped to 1 in our codomain. Therefore, it is not 1 to 1 because our image of 1 has two pre-images, which are negative 1 and 1. So here, this is not 1 to 1. Okay. A function is said to be onto or a surjection if and only if for every element of P that is an element of set P, there is an element of A that is an element of set A with f of A is equal to P. Okay, a function f is called surjective if it is onto. So by the definition of an onto function, it says that all the elements in our codomain must have a pre-image or must have a mapped domain value. So here, let f be the function from a, b, c, d to 1 to 3 defined by f of a is equal to 3, f of b is equal to 2, f of c is equal to 1, and f of d is equal to 3. Is f an onto function? Since all three elements of the codomain have an image, has a pre-image, or since all the elements of the codomain are images of the elements in the domain, we see that this function is onto. Now note that if we have here an element 4 for our codomain that is not assigned any value from our domain, then this would now become not an onto function, but a 1-to-1 function. Okay? So you really have to remember, when we are dealing with onto function, it means to say that all elements in our codomain must have an assigned value from our domain. Okay? Now here, example 6. Is the function f of x equal to x squared from the set of integers to the set of integers onto? The function of f is not onto because there is no integer x with x squared is equal to negative 1. Again, remember, our domain is the set of all integers and our codomain is also the set of integers. So let's say we have negative 2, negative 1, 0, 1, and 2 here. Negative 2, if our function is x squared, will give us 4. So negative 2 would be mapped to 4. Negative 1, if it's squared, will be equal to 1. 0 would be equal to 0. 1 would be still equal to 1. And 2 would still be equal to 4. We have here values of 2 and 3. Okay? 2 and 3 will never have a domain or an element in the set of integers of our domain, because there is no value of x, there is no integer x where you would have a 2 if you would square that value of x. Therefore, this is not onto. F of x that is equal to x squared is not onto. A correspondence is where we have a function of f that is 1-to-1 and also onto. Okay, the function is said to be an onto 1-to-1 correspondence or a bijection if it's both onto and 1-to-1. We also say that such a function is bijective. So here, let f be the function from a, b, c, d to the set 1, 2, 3, 4 with f of a is equal to 4, f of b is equal to 2, f of c is equal to 1, and f of d is equal to 3. f would only be a bijection if it's both onto and one-to-one. Since the function is one-to-one and onto, then this is a one-to-one correspondence or a bijection. Why is it one-to-one? Because no two values in the domain are assigned the same function value. It is also onto because all the 4 elements in the codomain are images of the elements in the domain. That's why f is a bijection. Now, the last thing that we would discuss in the introduction to the functions or introduction to functions is the composite function. Okay, let G be a function from the set A to the set B, and let f be a function from the set B to the set C. The composition of the functions f and g, denoted by all elements A in set A by this symbol here, f composite g, is defined as f composite g of A is equal to f g of A. Okay, how do we do that? Now let's try to have this example here for you to better understand the composition of a function. Let f and g be the functions from the set of integers to the set of integers defined by f of x is equal to 2x plus 3 and g of x is equal to 3x plus 2. What is the composition of f and g of x, and what is the composition of g and f of x? Now, to solve for f of g of x, this is simply f g of x, right? Where the function g of x becomes our x, or where we have to substitute our g of x to the x's in our f. And that would give us f g of x equal to 2 times, here we have to input or substitute this function to the variable x, so that would give us 2 times 3x plus 2 plus 3, which would give us 6x plus 4 plus 3, and simplifying or combining like terms would give us 6x plus 7. The same thing that we have to do with the composition of g and f. This is just g of f of x, which would give us g of f of x. This would give us 3 times 2x plus 3 plus 2. Distributing 3 would give us 6x plus 9 plus 2. Combining like terms, this would give us 6x plus 11. And that is how you do the composition of a function given f and given g.